Greetings, everyone. In this exercise, we are going to learn a very nice little trick where we can name our cells and use those cells to simplify our formulas. And we're also going to enter some formulas that are a little more complex and give us a chance to talk about something called operator precedence and associativity, which is it's an important issue to understand when you're entering complex mathematical formulas in Excel, which we do a lot in engineering. And so the use case here is we are going to do some calculations associated with the trajectory of a projectile. So this would be like if you fired something from a cannon or shot a gun or something like that, or threw a rock in the air or a snowball. What path would that take? Sometimes I like to refer to this as the Angry Birds exercise. So most of you are familiar with the very famous app for cell phones where you use a big giant flipper to send a bird into the air and crashing into some various things that the pigs have set up. I guarantee you in that app they use the same set of equations. And so we're going to have the user enter an angle in degrees in cell C4, and then the velocity in feet per second in cell C5, and then the coefficient of gravity in cell C6. And then we're going to use these formulas, which this is part of basic physics. Sometimes this is a branch of physics called dynamics. And if you ever take again, an engineering degree, you'll take a course in dynamics where you'll discuss these equations among several others. And so the first equation here is the range. Now, by the way, let's talk about the context here. We're assuming, for the purpose of these calculations, that we have a local coordinate system where the projectile is fired from the origin of that coordinate system. And the angle that is fired is alpha up from the horizontal. And the initial velocity is v. And then based on that, really the only inputs then are the angle and the velocity. And it then will travel a distance r, which is the range. And it will go a height h, is the maximum height. And so we have equations based on the velocity and the angle, and also the coefficient of gravity, the gravitational constant g. So we can calculate directly the range and the height. And also, you can calculate how long it takes for the total time it takes to travel that distance and return to the ground using this equation. And then, so let's suppose this equation returns a value of 5. It's going to be in the air 5 seconds. If you put in numbers for t between 0 and 5, you can use these two equations on the right to calculate the xy coordinates of this path as it moves along between the time of 0 and the max time t. All right, so let's go back, and we are going to use cell C8, C9, and C10 to calculate the range, the height, and the total time. And before we do that, however, we're going to talk about naming cells. Now, if I were to refer to the angle in cell C4, I would literally type C4 as that cell reference. And the velocity, I would type C5 or point at that cell, and the gravity would be C6. But what if, rather than entering those addresses like that, I could just type A for angle, V for velocity, and G for gravity, or some other expression? Well, that's possible. It turns out you can assign names to the cells in your spreadsheet. In fact, you can assign multiple names to the same cell. It's like having multiple nicknames. And any one of those work, including the original name. And so to illustrate this, I'm going to go to cell C4, and the way you do that is this cell, this little field right here shows you the name of the cell. And I'm going to highlight that, and I'm just going to type in A for the new name and click enter. And there you go. And I'm going to go here and type V. Now I could type velocity or VEL. You can do anything you want, but I'm just going to do V to keep things simple and to match my formulas down here. And then for gravity, C6, I'm going to type G and hit enter. All right. Now, let's see down here for the range. If I want to refer to those cells, I can say equals. Now instead of doing, C5 squared, I can just say V squared. And to square something, you do caret 2. Caret is shift 6. V squared times the sine of 2 times alpha. Now I'm going to just type it this way for now. Divided by G. And now I'm going to hit enter. Now the problem is I'm going to get an incorrect answer because it says negative 191,000 feet. Oh, that doesn't work. The problem is when you're using trig functions in Excel, you have to enter them in radians. And this is degrees. So to convert this angle from radians to degrees, I'm going to go in here and I'm going to type, there's a radians function, R-A-D-I-N-S. And so I'm going to put that 2 times A inside a radians function. And that'll convert it from angles to radians. There's another function called degrees where you enter an angle in radians, it'll convert it to degrees. So you can go back and forth, or you can multiply it by pi over 180. Does the same thing, but this is the easiest way. And you just always have to remember that. All the trig functions in Excel expect the angle to be in radians. And so if you enter something in degrees, you got to convert it. So now it says 97,000 feet. Holy cow, that is a lot. But 2,500 feet per second, that's like you're firing a shell out of an artillery gun. And by the way, this equation does not take into account wind resistance. So it's gonna go a long ways. That's about, that's close to 20 miles. That's traveling. Okay, the height. And you can change this down to a smaller number if you want, but we'll leave our 2,500 feet per second to keep things interesting. The height now would be equal to, now I've got to be careful here. Now this one, I've got 2G in the denominator, and I need to make sure that that 2G is properly divided into the numerator. And so I'm going to do things a little bit differently this time. I'm going to put everything in the numerator in parentheses and everything in the denominator in parentheses. And so I'm going to type equals open paren V squared. Now again, I can just type V. I don't have to do anything else. And I've got the velocity times sine radians A. And now I need to square that. Now notice what I did here. When you do sine squared, you don't do sin, caret 2 open paren. You call the sine function and then you square the result. So you got to be really careful with that. And then that's the end of my denominator, or excuse me, numerator. So I put a close paren there. Then I'm going to do slash 2 open paren 2 times G. So again, this is very important. If you read the chapter in the Excel VBA primer that talks about precedence and associativity, you may remember that when you raise something to a power, if you have a formula that has or an expression that has different kinds of operators in it, the thing that is executed first is a power sign, where you're raising that caret, and then multiplication and subtract and division, and then after that addition and subtraction. And so sometimes you can count on that precedence order for things to work out, but if you're ever in doubt, use parentheses. So for example, I need to put the denominator 2 times g in parentheses, because if I just said /2 times g, it would divide by 2 and then multiply everything times g, so g would end up in my numerator. So I got to make sure I'm really careful with that, but this should give me the right answer, which is 6,500 feet high, a little over a mile high. And then finally the travel time is equal to, there's just one thing in the denominator now, so I can be kind of lazy here now. Times sine. Lazy mean I don't need to use a bunch of extra parentheses. Divided by g, so 40 seconds in the air. That's a long time. Waiting for that shell to hit. So there you go. Now you'll notice the advantage of using the name cells is I can click on those cells and look at those formulas, and it looks very similar to what I'm seeing over here. I don't have to look at a bunch of cell references and kind of mentally make sure they're all pointing to the right cells. I can just use those cell names, and it looks great. Now, one thing that's very important to note is when you name a cell and then use it in a formula like this, it is by default an absolute reference. You can't name a cell and then use it as a relative reference, unless we do an array formula, which we'll talk about later. But in general, when you name a cell, it is an absolute reference. Okay? All right, now let's go down and look at our table. The next thing we're going to do is we are going to pick a set of times between 0 and 40.2, and we're going to put it in this column right here. And the instructions say, enter formulas for the t column in the table, have the times be a fraction of the total time based on the step number divided by 10. Okay, so we're going to go here, we're going to say it's equal to, now by the way, we're supposed to name these cells too, if I don't want to get ahead of myself. So we can call this one R. But by the way, watch what happens when I try to name a cell R. It doesn't give me an error message, it just doesn't take. It turns out there are two, as far as I'm aware, there are two names that you're not allowed to use for cell names, C and R. And I suspect that has something to do with C being short for column and R being short for row. So if you want to do R, I mean, you could call it, just spell it out this time, range. Oops. All right, now I'm going to do Control Z and undo that because I need to make sure I have just this cell named. By the way, you can name an entire range of cells. It doesn't have to be an individual cell. You can name a table using the same technique. So you could say, I could call this, my table, and there we go. But if I wanted to name this as range, I'm going to select that cell and do range. This we can call H. And this one I'm going to call it T, whoops, let's see, T, got to go up here, T underscore T, TOT, so for the total time, pick that out there, that's all right. And now down here, now we're back to where we started. Now, by the way, before I continue on that, if you ever decide you want to change a name, now let's, for example, if I look at that and say, that's kind of a dumb name, I want to change that. You cannot just go here and type a new name, because if you do that, it keeps the old name. The old name is still there. You just added a second name. So the way you edit a name, if you want to delete it or change it, you go to the Formulas tab and click on the Name Manager. And it says, okay, this one was an accident. I'm going to delete that one. Yes, I'm sure. And this one, maybe I want to name this a little differently. Maybe I'll call it total time or something like that. Okay, I can do that, and that works out just fine. I've renamed it. Okay, so again, to rename, to change or delete a name, you go to the Formula tab and the Name Manager, and that's how you do it. Okay, select a name, edit it, delete it, away you go. Okay, now back to this. We're gonna enter a set of formulas here that set up a column of numbers that vary between 0 and this total time t. And the way we're going to do that is we're going to take this number to the left and divide it by 10 and multiply it by the total time. Alright, so we're going to say equals this number, relative reference, divided by total time. Now when I click on that, you'll notice it puts in its actual name, and that is an absolute reference, which is what we want, and we're going to multiply that by, oh, excuse me, we're going to, I did that wrong. We should have sent A13 divided by 10 times the total time. There we go. That's what we want. We want that number to the left divided by 10 multiplied by the total time. And if we copy that down, you'll see now I have a set of numbers that vary between 0 and whatever this number is. And if I change my numbers up here, for example, I change my angle, it will automatically change this so that it always varies between 0 and this value here. Let me fix the display here so you can see it's actually the same number. There we go. Alright, so that's just a little trick that I sometimes use. And now that we have t values varying from 0 to the maximum or total time, we're ready to plug in our formulas for x and y over here. And x is equal to the velocity v times cosine of radians a times, and this is ti, the individual time, so that is cell B13. It's covered up, or I just select it. Now I want this to be an absolute reference. Everything else is, or excuse me, a relative reference. Everything else is absolute. And we'll hit enter. Copy that down, and now for y, we'll do equals v times sine radians a times B13 minus 1/2 times G times B13 squared. Okay, and there we go. Now, to double check to see if we have this correctly, they both should start at 0, 0, which is true. Y should go up to a value equal the height and then go down to 0. So halfway through here, you'll see that the y value equals the height. We calculated up here. And then at the end, it goes back down to 0. And x goes from 0 to the total range r. So it looks like everything is working correctly. So to review, we learned how to name cells. When you name a cell, you can type that name when you're entering a formula. You can type the original address if you want. And when you make a reference to that name, it's always an absolute reference. If you want to change a name, you want to use the Name Manager option in the Formulas ribbon. And when you're entering complex mathematical formulas, be very careful with precedence and associativity. Use parentheses when in doubt, and everything should work out great for you. So that concludes this particular exercise.